So in our second part of our three-part series on ionic bonding, we're going to discuss how to name and how to write formulas for ionic bonds that include transition metals. Okay, so let's start by learning how to write formulas if you have a transition metal present. The tricky thing about transition metals is that they can form more than one type of ion. For example, iron can have a +2 charge or it can have a +3 charge. Okay, so knowing which of those charges is present tends to be where people get tripped up the most when writing these formulas. So in the name of your ionic bond with a transition metal, you're going to see a Roman numeral. That Roman numeral is equal to the charge of the transition metal. So they tell you which one you're using right there in the name. So here are some examples. And we're going to work through these. We're going to use our previous rules, and I'm not going to go through the previous rules on ionic bonding, how to write a formula for those, because the rules are the same. We're just going to practice with these names that now have Roman numerals. So our first step is to always take our metal and to convert it to its symbol with its charge. For iron, we don't know what the charge is. Thankfully, there's a Roman numeral that tells us the charge on this particular iron is a +2 because it's a Roman numeral 2. So I know the charge is +2. For chlorine, I'm going to write the symbol Cl, and I know because I labeled my periodic table with all the charges that it's a halogen and it has a -1 charge. So iron is going to transfer its 2 electrons, because it's a metal, it's going to lose its 2 electrons to the nonmetal chlorine. So we're going to see a transfer there. Okay, so you have an iron that has 2 valence electrons, and you have a chlorine that has room for 1 valence electron. So one of these electrons is going to transfer from the metal to the nonmetal, but notice that we still have 1 extra electron. So what we're going to need to do is we're going to need to add a second chlorine, okay, so that we can transfer that second electron over. So what our formula is essentially going to say is that I have 1 iron for every 2 chlorines. The ratio is 1 iron to 2 chlorines, and that takes care of transferring those 2 electrons from iron to the chlorine, which only has the ability to take on 1 more valence electron. Now, that is using the charges to determine how to make a neutral compound. You can also do my favorite method, grab those charges, drop and swap them down to the subscript. So 1 becomes a subscript for iron, and 2 becomes a subscript for chlorine. Rewriting this because I never have charges in my neutral compound, you get FeCl2. So either approach is going to work, just so long as you double check and make sure that you can't divide both of the subscripts by the same number, and if so, you need to reduce it. All right, next example is copper 2 sulfide. So let's start by writing the symbol for copper, which is Cu. Copper is a transition metal. I don't know what the charge is, so I'm going to look at the Roman numeral. It tells me we're dealing with copper 2, which has a 2+ charge, and sulfur is a symbol S, and sulfur has a charge of -2. So now I just simply drop and swap, and when I do that, I get Cu2S2. Well, shoot, the subscript are equal to each other. That tells me, because they're both divisible by 2, that really I only need these in a 1-to-1 ratio. So I'm going to make sure that my final answer does not have any subscript because they were the same subscript. So it's a 1-to-1 ratio. Our last example is tin for bromine. Now, tin is not a transition metal, but it is in the carbon family, and remember that they can either have a charge of +2 or +4. So whenever you write tin, you need to be sure to include the Roman numeral with it, so I know if you're talking about the +2 tin or the +4 tin. So tin's symbol is Sn, and from the Roman numerals, we know that this has a +4 charge. It is with bromine, which is Br. It is a halogen, so it has a -1 charge. So now, again, I like using the drop and swap method. I'm going to take those charges and I'm going to drop and swap them down to the subscript. So tin now has 1 tin for every 4 bromines. Okay, so we have 4 electrons are being transferred to bromine, but it only has spots for 1 electron. So I'm going to need 4 different bromines to accept all of those electrons. Again, we do not write the 1 in our neutral compound. Notice that my final answer has no charges in it. You guys are going to get to see every glorious inch of my dirty office as I keep turning to try to avoid getting sun glare in my eyes. All right, so this would not be chemistry if it weren't for the exceptions. So there are some exceptions to writing formulas with transition metals, and the two that we're really concerned with are silver and zinc. Now, even though they are transition metals, they don't have more than one charge. So silver is always going to have a +1 charge, and zinc is always going to have a +2 charge. So a lot of times when you see these names written, say you have zinc chloride, yikes, right for me, it's not writing. You are going to see them written as silver chloride or zinc chloride, and you're not going to see any Roman numerals there. So you're going to need to memorize these two. Cadmium is our other one, but we don't really use cadmium much in this course. The other exception is for tin and lead. Now, tin and lead are in the carbon family, so they have that +2 or a +4 charge. So you're going to treat them as a transition metal as well. Make sure that you put their charge when you're naming them in as a Roman numeral. All right, and some other ones that you need to know, particularly for nursing, are the common names. So sometimes, and it was more of a common way to name things before we became more systematic, is to add the suffix OUS or IC to the end of the word. So we'd take the common names, and then either if it's a lower charge of the two, you would give it the OUS ending, and if it's a higher charge, you'd end the word in IC. So for example, we see this in ferrous versus ferric. So that is the common name for iron. So the OUS tells us it's a lower charge. Well, I know iron is either a +2 or a +3 charge. So OUS is going to tell us that it is in fact a +2 charge, and IC is the higher charge, so that is the +3 charge. So we see this, I think, more in medicine. Like if you had somebody who was anemic and needed iron supplements, you're going to see them taking ferrous chloride or something to that effect. I don't know what they're going to do to make a salt out of it, but you're going to either see ferrous or ferric in the name of that particular drug that you're giving. The other one I need you to know for this class is cuprous versus cupric. Copper can have either a +1 or a +2 charge. So again, OUS tells us it's the lower charge. So I have to know that copper is +1 or +2 in order for this to work. So cuprous is a +1 copper, and cupric is a +2. So in practice, I may have something like cupric bromide, and that tells me that this is copper with a +2 charge, and bromine has a -1. So the way I would write this formula, if I'm dealing with cupric with the higher charge, it's going to be written something like that: 2 bromines for every 1 copper. All right, so let's go through. We talked a lot about formula writing, and in that we got some hints as to how to name ionic compounds that have transition metals, but let's go ahead and write down the rules for these. So the first step is to name the transition metal first. You're not going to change anything about the name, it's the metal. You will have to determine the charge of the transition metal, and to do this, really the best way is to look at what element it's bonded with, determine that charge and how many you have. So you're going to have to use some math for that, but it's pretty minimal. The charge of your transition metal, whether it's a +1 or 2 or 3, is going to become a Roman numeral in parentheses, and it's going to come right after the name of the metal. You're going to take your nonmetal and you're going to take the stem away from it. You're going to drop the ending, and you're going to add the ending IDE. So again, chlorine would become chloride, bromine, bromide, oxygen, oxide. And again, the more you do this, the more natural it's going to feel, and you'll have an idea of what you're doing. Let's go through some examples. So now that we know that it is possible to have these transition metals, we need to be aware. Every time you see a metal in a compound, you need to think, is this a representative metal? Is it one that has a single charge, or is it a transition metal? And do I need to write the name therefore with a Roman numeral? So iron is in fact a transition metal. So let's start by just writing the name out, iron. Now I need to determine what's going to go in these parentheses, and I'm going to hold off on that because I'm going to just get the rest of the name out so I don't forget. It is bonded with chlorine for the nonmetal. I take the stem of that, chlor, and I change the ending to ID. So I know this is iron chloride. What's left for me to determine is it iron +2 or +3? So looking back at my formula, I have 1 iron bonded with 1, 2, 3 chlorines. Each of those chlorines has 7 valence electrons, and I'm only going to show you this on the first to save some time. Okay, so I know that each of these chlorines can take on 1 valence electron. So this iron, and there's only 1 of them, has to have 3 valence electrons to be able to give each of those chlorines that I'm told is in my compound. So therefore, the charge of iron has to be a +3. So in Roman numerals, I will put the number 3, and this is iron 3 chloride is how you would say that name. All right, let's apply the same example for chromium oxide. So Cr is chromium. I'm going to leave those parentheses. I haven't determined the charge yet, and we're going to finish off. Oxygen becomes oxide. And now I need to go back and determine. Well, now this time we've got something funky going on. Okay. I am going to do this approach just a little bit different to show you a different way that you can solve this. So if you're not a visual person and drawing it doesn't work for you, but you're more mathematically inclined, this approach might work better for you. So I know that I have, according to my subscript, I'm going to erase this so we can actually see what's going on. According to my subscript, I have 2 chromiums. I don't know what the charge is. Okay, but I also have 3 oxygens. Well, I know oxygen has a -2 charge. And I also know that whatever these positive charges are have to equal the negative charges, because when I add the positives and the negatives, they're going to have to form a neutral compound, and my overall charge has to be 0. So I know that 3 times -2 is a -6. So whatever I multiply by 2 here has got to equal a +6. So 2 times a +3 gives me a +6. Well, +6 and -6 does in fact equal 0. So that is another way to determine the charge of that particular transition metal. So you can do it mathematically, looking at, how can I solve for this to get a neutral compound when I add my positive charges and my negative charges together? Or you can draw the Lewis dot structures and see how many you need to transfer for that. Either approach works. Make sure that you double check that your compound is neutral though.